Sir,
Yes, please.
in this course, we have any MATLAB work or not?
No, we don't have MATLAB. We have another ID which it will be a start from today, and we will work on that. Okay, today we will have one talk regarding the software in embedded system design process, and design life cycle of an embedded system. This part is somehow very important because the designing of the embedded system process we will talk, and it's something that really we can say there is not any written rule for that, but a big but is that people will follow some step to do the designing job. Today we are going to talk regarding that, and we will analyze these steps from 2 points of view. One is from some general embedded systems person, and second one is from one book that recently I also shared part of that book for you as the reference, and you can refer to that. It's one of the good book in embedded system design, but little bit I feel that this book is old. That is why some part I use from this book. Then first let us see what is the embedded system design process. In other words, if I want to design any embedded system, which process I should follow or which step I should pass to reach a compact design. As I already tell you, this process, some part will be add, some part will be minus from the steps that I will tell you. But in whole, the package that today I will tell you, it's little bit, we can say it's general for designing the embedded system. First thing can be like this. First, you should know what the requirement you have, and then based on your requirement, you should design the architecture. Then select the OS that you want, choose the processor and prefillers that you need. Then choose the development platform, and then do the codes and application and try to optimize these steps. After that, you should verify the software on the host system, and finally verify the software on the target system. First, let us see what is system design architecture. System design architecture that you are going to select will be depend on whether the system is real time or not, whether the OS need to be embedded or no, size, cost, power consumption, and etc. are the factors which help you to select the architecture. Manufacturing cost, I mean, if we want to make the bulk from my embedded system, how much should be the bulk production? What should be the performance in overall speed and deadlines? Suppose what should be the lifetime of the system that I will select? And main things is power consumption. Let me tell you one truth that mainly the today problem for embedded system is power consumption, because we have lots of controller, microcontroller or microprocessor that we can select. But as we are going to go to the battery-based system nowadays, and especially charging battery, then this power consumption item, it's become more and more important and critical for designer to select the system. Let us see the design system. First, I tell you we should know the requirement. I mean, requirement could be the functional or non-functional, and we must capture the basic function of our embedded system. But Functional description is often not sufficient, and typical non-functional requirements we need, which are include first performance. I mean, as performance, we define it as the speed of the system is often a major consideration, both for ability of the system and for ultimate cost. We should know that performance may be the combination of the soft performance matrices, such as approximate time to perform the user level function and hard deadline by which a particular operation must be completed. And the other non-functional requirement is the cost. You uh, mainly, maybe this example is not the good one, but truly speaking, if we think this much low level for the embedded system, it's not bad. I mean, if you think that you want to have the design one embedded system, something like a toy with that much quantity, you know that when they make the toy, at least they will make 1,000, 10,000, something like this, based on the type of the toys that they want to make. Okay, you should know. Suppose if I made 10,000 of these specific toys, what should be the cost? Think, I want to make one toys which has suppose 6 screw, 5 gear, 1 DC motor. Okay, with the battery and without the battery, what should be the total cost for me? Because I should see that my customer afford to pay for that or no, or will be ready to pay for that. You know that most of the product in the world now it's like that. Suppose they will decide to make it with some fixed rate of the amount. It's also is not a simple job and need lots of experience, especially in the embedded system world, to have the successful product. But somehow, after some years that you are working in embedded system and selling the product, you will have this ability to tell, suppose, these special toys, or let us see washing machine. This special washing machine target should be this much, that you can sell this much quantity. Then think like that. The cost or target cost of purchasing is one of the most important things when you started to design a system. Even for the next part of our embedded course, which is belong to Arduino part, I will tell you that maybe same functionality you can make with small amount of money, and then maybe uh, with the bigger board, you will have not much more functionality than the cheapest one. Even there is some difference between the controllers, I mean the speed of them, but you should know that exactly what you need and what is your target cost. Um, for some fresher like you, target cost is not, I think it's not simple. Even sometimes for me, it's not simple to estimate the target cost. But anyway, this is the things that you should see. These costs have the manufacturing cost, which is including the cost of the components and assembly. And another thing is that the word that they call it on air RE, or non-recurring engineering cost, include the personal and other costs of designing, making the prototype, do the R&D. I mean, from the first day that you start to work on design the embedded system till the time which it's become product. Let me ask you one question. When something wants to become the product, can anybody tell me which step we should pass? Or how many steps we have from the designing till the time that it's become the product? Who can tell me?
There's research and development, and then there's um, okay, from designing, then there's production, and then I don't know if I think I'm missing quite a few steps.
Not bad, Kaya. You are not much more far away. But I want to know other person's idea. Sajid, can you tell me? Now I think we don't have delay. Then if you don't answer me, it means that you are sleeping. Any other person? Hossein, can you answer?
So design steps, manufacturing cost including like when we are doing design, like it should be simple like this, simple that can easily understand others, and
Okay.
performance will be very good.
No. Let me tell you one truth. First things that suppose today you will design to make one washing machine. Okay. First shape of that washing machine is very ugly, but it will do the work for you. Means that it can wash. Okay. But if you want to sell that design, nobody will purchase that. Because from the designing aspect and appearance of the product, it don't have the good shape. Generally, people will use some general purpose board for suppose electronic section. They don't have the PCB. And sometimes that system even works, sometimes it's not working. You have some prototype age, I call it. It's something like newborn baby that you should slowly give him the dress, and then it's become up and become nice. Understand what I say? Then the first part for the R&D is exactly that prototype, which the shape of product is not good, but it has some performance. Step two in the R&D part is the part that the system working, but you little bit change the shape, and that is why R&D part will take lots of time. 2 year, 3 year, 4 year sometimes. And then product time will take suppose maximum 1 year. That is why all the time they have lots of research and development in big companies. But the line of production is little bit, we can say, same along the year, and twice a year. One after 2 years, not twice. After 2 year, after 3 years, they will change the product. Understand what I say? I mean, after this prototyping stage, we will go for design step one, which in design step one, they will reduce the extra wiring, suppose, make it better, shape is better, little bit it has design, but till the product, still there is the long way. Then some specialist will come and see the product, try to make it better, reshape it, even put some interesting shape, designing with some 3D modeling uh, software, and like this, they will going to do the step of design number one. When design number one or product number one will be finished, then you will see that year by year shape will be changed. Revision 1, revision 2, revision 3, revision 4, till the time that it's established that, okay, this is the last version. Suppose, see the mobile phone. as one company, suppose I don't know, Huawei, P9, suppose P10, P12, P13, P14. Truly speaking, just they will change the processor and just add some part to that. The platform is fixed, and just they will change the appearance. Suppose change the place of camera from right, put it at the top, top put it at the middle, middle to the left. As you see, the generation of the mobile is like that. Add two camera, remove one camera, add four camera, remove one camera, add two flash, add three flash. Can you see all? That is exactly the design steps, but all the R&D parts will happen before. That is why this NRE cost is the cost which you cannot it don't have the simply visible for you. But on the other side, you maybe spend a lot of money for 2 year, 3 year to one engineer who sit and design and make your idea run. Understand? That is what we call on cost, which is more important, especially for the embedded system part. Third part is the physical size and weight. You know, the physical aspect of final system, I mean the final product, can be very greatly depending upon the application. For example, some industrial control system for an assembly line may be designed to fit into the standard size rack with no strict limitation on weight. But some handle device, they have the restriction of the size, restriction of the weight, and maybe the working situation. That is why this part, I mean the physical size and weight, other than appearance, is more important for the designing steps. Power consumption, I tell you that it's an important battery powered system and is often important in other applications as well. Then power can be specified in some requirements stage in terms of battery life. Next is selecting the OS. If OS we need, we can select the real time or non-real one. Uh, Already we talked about RTL Linux, VxWorks, huh? Some RTOS part, VRTX, PSOS, QNX, and so on. Or some non-real one like Windows C, embedded Windows XP, and so on. We talked regarding this difference between these OS last lecture. Then the next step is choosing the processor. Now it's clear for me what should be the weight, what should be the size, what should be the real or non-real time performance. Then I should select a processor for that. We can select any of the following processor. But suppose you can see in this list Arduino and Pi is not there, which already now they open the gate to the embedded system product even, and they can be used. But different processor like 8085, Pentium, Peak, AVRs, Arduino, we can, because they are using the core of AVR, maybe I didn't bring it here. MSP1, MCS1, and DSP ICs or Share or Tiger Share, as well as so many processor that you can use and select. But you should know the previous requirement and then select the processor from these steps. Then after that, what should be my development platform? The hardware platform can be the operating system, programming language, or development tools. One of these can act as my hardware platform. Then coding application, which language we are going to select. I'm going to do with assembly, I'm going to do with C, C++, Java, Python, and then optimizing code, which I want to do. Then the next step is the verifying software at the host that we will do the compiler to see the errors and do. Suppose this compiler is regarding the assembly language. With last semester you had lecture. I think maybe you work with this or something like this. some software like this to verifying your codes and finding the error. Then after by software and simulator you verify your code, this is the next step, which you are going to use the real hardware and download it into the programmer device by using the programmer device into the ICs. In this stage, you should use the emulator or on-chip debugging tools to verifying the software. Suppose here I use the Arduino or some another board, some microcontroller, AVR jobs, that most of them try to test the program that it's written before. This step that I tell you, it's from one look, from one reference. I found some nice point in Raj Kamal embedded system book, which from that also we can review. Means that the process which followed for designing an embedded system can be like this: abstraction modeling, hardware and software architecture and external function, properties, system related family design, modules and mapping. Let us see them. In good design, what we know is that to have the good design, each problem components first should be abstract. Suppose with the example of washing machine, my problem is that I should wash my machine, my shirts in the proper way, that the speed should not be much and speed should not be low that can suffer suppose 7 kg of the shirts, and also it should not damage my dress. Second point. Then the third thing is that the system that I use should have some specific feature which depends on the type of the shirt I can select and changing the mood. Then in overall, to have the good design, each problem components first should be abstract. Suppose if I want to wash proper, I should know some specific sensors that can check the output of my washing machine, and if the shirts output are still dirty, again the cycle should be stopped. Or for example, displaying pictures and text as an abstract class, robotic system problem abstraction in terms of control of motors in different degree of freedom. Application software abstracted as concurrently running the multiple threads and interrupt system service device. These can be some initial point for us. Then we will go for modeling part, which we have procedure-oriented one, which has the class, objective, interfaces, and package. We have objective-oriented, sequential process, concurrent process, and state machine 1. Then design of hardware and software architecture is the next step, which in that we will assume to consist multiple layers. Each architectural layers will be understood before the design, and then we can use it. Design of extra functional properties. You know that this type of function required in the system being developed, well understood from the design. Next is system recall family design, which families of related system developed and earlier taken into consideration during the design. Next is modular design, which in that we will do the decomposition of software into modules that are to be implemented, and modules should be such that they can be composed or complete or integrated later. Effective modular design for us should ensure some effective like that function in the independence, it should be cohesion, and it should be coupling. Uh, this part, I mean, modular design should be carefully understood and maintained continually. Appropriate protection strategies are necessary for each module, and a module is not permitted to change or modify another module functionality. For example, protection from a device driver modifying the configuration of another device. Next part is mapping, which is mapping into various representation done considering the software requirements. For example, data flow in the same path during the program flow can be mapped together as a single entity. Transform and transaction mapping. For example, an image is input data to a system. It can have the different number of pixels um, and color. And transform mapping of image is done by appropriate comparison and some algorithm. Transaction mapping is done to define the sequential of the suppose image. Then the next part is UI or interface device, UID, which design as per user requirements and analysis of the environment and system. For example, in an automatic chocolate vending machine system, some user interface like LCD matrix can work. It can display a welcome message as well as specify the coins need to be inserted to the machine for each type of supposed chocolate. And same electronic chocolate machine may be designed with touchscreen GUI or with visual user interface one, and a GUI or visual user VIP visual user face interface can be again the matrix display. Next is the interface design validation customer, which for example the customer must validate the message language, screen logo, screen icons and background colors, wallpaper, menus and dialogues before an interface design can proceed to be implemented stage. Testing, verification and validation is the next step, which is testing. We are going to find the errors and to validate the implement software as per specification and requirements to get reliable product. Verification is referred to an activity to ensure that a specific function are correctly implemented. Validation refers to an activity to ensure that the system that has been created is as per as requirements arranged upon the analysis phase to ensure the quality. Modules as the next part should be clearly understood and maintain continuity. I mean, in using the modules part, appropriate protection strategy we should have for each modules, and a module is not permitted to change or modify another module functionality. For example, protection from a device driver modifying the configuration of another device. Refinement means that each components and module design need to be refined it's relatively till it's become the most appropriate for implementation by the software. In whole, abstraction of design process steps to top design, if it's built starting from the component, a design process top to down, if it's first starts with abstraction of the process, and then after abstraction the details are created. From top to down design approach is most favored approach. Let us see the activities for software design during the software development process. Suppose we have the model analysis, requirement of the system. Then in the design, we have the data structure, software architecture, interfaces and algorithm. Then we have implementation of design. We have the test, internal logics and external function. And all these part, we know the one life cycle of the development process. Let us see it once more. What we have some requirement. We should complete clarity of required purpose and inputs, output, functioning, design matrices, and validation requirements for finally development system should be there. Step 2 is the specification. We will clear a specification of customer expectation from product, needs of them, device processor and memory specification, and data type and processing specification we should have. Or we need some specification of expected system behavior, consentence of degree, expected life cycle specification of the product, and process specification analyzed by making list of inputs on events list and output on events process. The third part of abstraction levels is um, architecture, which in that we should know the data flow graph, program models, software architecture layers, hardware architectures, interface design, and system integration, which based on that we can go to the next step, which is the selecting the components and system integration part. These was the 5 level of abstraction that we should have. The next is the software architectural layer, which it will shows how the different elements, data structures and database, algorithm, control function, state transaction function, process, data, and program flow are to organize, and what shall be design of data structure and databases. What should be the most appropriate for the given problem? Whether data organized as a tree like a structure will be appropriate, and what will be design of components in data. We have hardware components also, which we use the processor, ASIP, and single purpose processor in the system. We have memory, RAM and ROM, or internal, external flash, or secondary memory in the system, peripherals and device internal and external, ports and business in system, power source or battery in the system. These are the points that we should remember when we will design the system. We reviewed from 2 points of view. One was a bigger one, and another one was the small idea to design the embedded system based on your requirements. We will go for the next part, which is the embedded design life cycle. If you permit me, I'm going to do it. Any question till now from student?
No, sir.
No, sir, no questions.
Okay, good. The next part is the life of the embedded system, which this part is also very important. The main purpose that I bring this life cycle is that you should know one thing. For example, today you will decide to change your mobile phone. How much you will validate that this price is okay for you or no? Can you tell me?
By looking at the specifications.
Okay, good. Then,
And also the features.
okay, next. Suppose if I tell you this mobile phone is 1000 RMB, how you can calculate it, that you buy this or not buy?
Well,
By the
we
configuration,
should
sir.
see the features and the
Okay, feature you will
popularity.
see, and then what you will do?
The configuration of phone.
Okay, then what you will do with that configuration?
The storage and then the RAM. All these things.
These are the configuration. Then,
No, the thing is, I think we should see the usability and usability in the sense like how efficiently we are using the phone according to the price.
yes, it means that Reza wants to say that if I want to spend 1000 RMB on this mobile phone, can I get at least near to 1000 service from this mobile or no? On the other way, is it cost or no? This yes or no depends on your pocket, but you will decide.
Obviously, sir, we should decide because I'm spending suppose 1000 RMB, so I should get something better, right? Something how to say
How long I
like
can use the phone? It depends, right?
yeah, durability, everything we should keep in mind. Suppose we're it is some kind of investment. So if I'm investing 1000 RMB, how long it will go, how I can work, in which purpose we can use these things, something like this. Suppose if I'm buying, suppose the old Nokia phone by 1000 RMB, that's really, I don't think that much effective. But if I'm buying a new Android phone, that might be because like now new generation, the generation we're using, that is okay. But even the previous generations phone was also like Android was also not that much developed comparing to today. So yeah, we should keep these things in mind.
Any other opinion? Any other opinion? No? Okay. Well, I think some of them again sleeping, but I will continue. Uh, you are right. Means that there is the point that you should, when you are going to buy a system, you should know that how long you should use it and then spend for that. Same things when you design the system, you should uh, think as the customer part and life of the system that you will use. Due to the development in microelectronics, uh, we have some good things. One is that we could reduce the cost, increase the speed, reduce the size, and reduce the power. But the embedded design life cycle have something like this. Unlike the design of the software application on a standard platform, we have the design on an embedded system implies that both software and hardware are being designed in parallel. Although this isn't always the case, it's reality for many designers today that they perform implication of this simulated design process heavily influence how systems are designed. You will see some phase here in this photo. Phase one is product specification. Phase two is software and hardware part. Phase three is iteration and implementation. Phase four is detail, hardware and software design, which in that we have hardware design and software design paths activity. Then we have phase five as integration of hardware and software, and acceptance testing, and maintenance upgrade. At this point of the acceptance testing, we have the product. Okay, I found from this book Arnold Asperger about the embedded system design. And this will give you the nice things. Even you, whenever you will do any project, you can have this life cycle. But this phase represents of embedded system life cycle, and time flows from the left and proceed through the seven phase as we said. Product specification, partitioning of the design into the its software and hardware components, iteration and refinements of the partitioning, independence hardware and software design tasks, integration of the hardware and software components, product testing and release, and ongoing maintenance and upgrading. We have some graph like this, which in that we will do the system specification and design as the 37% of the work. We have 51% of the work, which is have the hardware and software development and debug and prototype design, and we just have 20% of systems, which is have 12%. Then by this life, you will see that till here we should spend lots of money till the test, and then from this part we have the maintenance. That is how we can calculate the cost of our embedded system based on these 37 and 51% of the job, and then 12% is the system test, which regularly it will not come to the cost of the designing embedded system. Then, as we talk regarding this part, again, I will not come, but what I want that you know, that you want to do something like that. You assume that we have one embedded system and try to write the consideration for design and development of that. And suppose if you want to design it, which hardware you need, which software you need, how much time you should spend on this part. And let us, I don't know, take one common example as the mobile phone, and then based on that embedded system, try to make up the features and also see the consideration of design. It's not the bad practice for you. Even if you can calculate the cost of one, maybe it's great, and then you will see that the something that you will take, it's much more cheaper than the price which people spend on the designing of this embedded system. And why the price is less? Because they will sell it in bulk, and they assume to return back their money within 1 year, 2 years, something like that, based on the business plan that they have. Okay, I think it's okay for the first part of today. What change we have for our class is that we can now you should send the answer through the mock system, and by that I will give the mark. Also, the previous task I give you the mark. It's my request that if it's possible, the person who have the mark for previous task send their task to the system again, that I will give them the mark, and then little bit I think this the job for this semester for me become simpler, because now we have the good web page in university. Any question, any doubt regarding the first part that we talked today?
Sir, who send the assignment in before your email address? Is this okay?
If it's possible, please send it to this system today.
As a PPT, right?
Yes, exactly. Just PPT, but send it to the mock system. The university also insists us to use. I think it's not bad to using that.
Okay, sir. No problem.
Okay.
Okay.
Any more questions?
No, sir.
Okay. No question. Okay. I think we had the lectures for 55 minutes. It's okay. Then we will have take rest for about 5 minutes, and then we will join again. If you don't have question, or if is there any point that you want to what we can say
Sir, yeah,
discuss with me?
from task 1 to task 4, all of them we have to submit in mock now.
The person who sent previous, now they can send. The new
Yes,
person,
sir.
no. Yeah. Turn on your camera that we do the attendance, and then we will stop. Fast, please. And are you okay with this system? Kaya, what did you do? Show your face. Remove that background, please. Remove that background. Kaya. I don't know. Always he wants to. Let me see. I also open my. If it's okay, Roy, let me go to a start.
Yes, sir. Let's start.
Okay, good. Now, till today, what we discussed, that was some general concept, some general definition about the embedded system design. And what we will go for the rest of our lectures, we are going to concentrate on one specific controller as, first is Arduino as the microcontroller, and second one processor that we call it Raspberry Pi. We are going to talk. For this semester, I have done some change on the syllabus and add some more uh, part for that, especially for your course, because you have the MD course with me. And try to make this course little bit update than usual, because embedded course should be the have some recent aspect which help students future in careers and also finding the job. Anyway, what we are going to talk today is we are going to talk about nice controller board that we know it as the Arduino, and we are going to talk about the various type of Arduino. First of all, before going to Arduino board, for 2-3 slides, I talk about one concept that people talk about it and call it IoT or Internet of Things. What is your idea about Internet of Things? I want that. Let us Saddam tell us. Saddam, what is your idea about IoT or Internet of Things? What is that? Please don't read my PPT.
Sir, I think it's one of hardware board like mm,
Just one hardware board means that all concepts are related to hardware. Moshi, what do you think?
About
Moshi.
IoT?
Yes, about IoT. No idea. If you don't have idea, tell me no idea. It's okay.
Yes, like it's IoT. It's like it's the technology that's totally based on like internet. Okay,
And do you think how it can change the future or how it changed the future? Wake up. Okay, if you don't know, you can tell me that I don't have idea. It's okay. But we
yes,
want
so
to,
maybe
yeah, no
I'm
problem.
confused.
No problem. We are coming to the lectures to learn. If we know everything, then there is no point for coming to the lecture. Just I want to know that how much you think about this IoT. You know, this IoT is the abbreviation of Internet of Things. As I said, it's one technology that's going to change how we live and how we interact with the device. The project that we have in IoT, all the physical objects are connected together and using the internet infrastructure. I mean, whatever device that we have with some methods, with Wi-Fi or with LAN or the cable or any other things that currently we have Wi-Fi and LAN. Maybe someday some new technology will come, but it's try to connect the device one by one to the internet and to each other. Okay, one of the board that nowadays or recently introduced, recently I mean after around I think 2010, still 10 years. This part of IoT part it takes around 10 years like that. Come to pictures with this feature of IoT is Arduino. But what was the idea behind this IoT job and Arduino board which they are crash each others? That was one method of programming that we call it open source programming. Can you tell me open source programming is good or bad? Let us, Jahad, tell us. Open source programming is bad or good? Kondakar Jahad. Okay, I think he is also missing the lecture like this. Kaya, can you tell me it's good or bad?
It's definitely a good thing, sir.
Means that I will do the coding and you just coming and use it. Is it good? What about my right? I'm a coder. I will do all the codings and put it on the net.
Yes,
And you just come
yes,
and copy it and use it.
yes, but
Not possible for developing.
Is it good or bad?
It's good,
it's
sir.
good, sir. It's
Okay,
still
it's
good.
good. It's good for you. But what about me? Just right now, I talk about the process of the embedded system. That first part, we should spend a huge amount of money on R&D section. And one part of this R&D section is software development. Yes. Then if I share all my code with you, and a company spend lots of money for me, then where is that money? Where it will go?
It will go into the community, sir.
Community of what, Kaya?
No, actually, Kaya, what sir is saying,
Developers.
like all the sir's effort, like suppose you are doing some work and we have done nothing and we're just using it. So
Yeah.
in this case, what I will say, sir, if you want no one to use your thing, so you can have copyright or you can have restriction on that. But if it's for global use, suppose you want me to use, and if you publish like that, we will use. In this case, I think we have both parts. Like we can get benefited. We can also get like get to know
Yes,
how we should code,
I,
like how it
I
works.
want one thing.
Yeah.
I want one thing. Let us make it clear in this lecture. Just you tell me that if I share my code, that suppose 1 year, okay, 1 day I spend my time for that, and suppose my time is $100. I will share that $100, and all of you will come and just use it. Okay? Then where
Okay.
is the benefit? From where
Benefits
this
in the sense,
$100 should come back to my pocket?
you can come back. Suppose you shared
Donations.
that $100 box, and we are suppose some students like us are using that. So that means like somehow you're making a community, as Kaya said. Maybe in future you can use our help
Reza, this
only if
is
you want.
the market. I should take my money at the right place, right date. Okay? I'm
Uh-huh.
not working for future. I'm working for next week. Next week I want this $100. If really open sourcing is like that, that you are coming and copy my code, then exactly I have the loss, and that loss is that this is suppose $100, $200 per day.
But
From where that money will come back?
open source is not exactly you doing all the work. It needs collaborators, which means other people will also join in and help you with the
Yes,
content.
some part is like that, but that joiner and persons who also join in coding section for me, okay, who will pay for them?
Donation.
The customer or the buyer who wants that,
Okay, then who will pay for that person?
I
like
mean,
whoever will
donation.
buy. I'm buying from you. That means
Donation, how
I will
much
pay.
donation you can do? How much, who will do the donation in the world?
It depends on your work. If your
Whoever is
work is
having money,
good,
The
sir.
then
sponsor will give the
sure.
donation.
And
No.
you,
Please think logically. Okay, for this type of question, there is one good example. That example is Bluetooth communication. What did happen to Bluetooth communication? When they developed the Bluetooth, they didn't hide the protocol, they didn't hide the sample work, they didn't hide the hardware part, and then Bluetooth come to lots of products: watch, hands-frees, AirPods, mobile, and so on. Now, what is the benefit? Benefit is that the person who make that Bluetooth and share the code for all people to develop the project on that, it's something like that. Feed some person free food, but on the other side, they will earn by selling the chips, selling the, I don't know, some slowly new chip, new version, like that. You know what I mean? They will give some food, and then you addicted to use the foods from them. Understand what I mean? And we have the one
Yes.
example for one OS that they didn't share. I tell you, Bada for the Samsung, and compare Bada and Android. They hide the Bada and they expose the Android. Now tell me, where is Bada? Where is Android? Okay, then all
Yes.
of these results shows that open source programming is good because it can make the developer work faster. But on the other side, Developer, if they use, suppose, specific boards, they will continue to do that with that. They will do the foundation based of, suppose, Arduino board as the open source, and then they will have the product based on Arduino. Then the Arduino company is the person who will take the more benefits from this person. Agree or no?
Agree,
Yes,
sir.
sir.
I
Agree.
agree, sir. Understood. I understood your point.
Then if any person tell you that where is the benefit for open sourcing, first thing is that today's scenario of programming is that nobody will start from the foundation. People will use the API jobs. People will use the library part. People will use some prior codes, and then they will inject their application inside that codes. This is the first. Second thing is that in the open source programming or open source programming concept, the main benefits, again, you have lots of benefits for that. Let me tell you one old example. Windows and Linux. Which one you should pay?
Windows, sir.
Windows.
Definitely Windows.
Yes,
And
sir.
what about which one is better? Linux is better or Windows?
I think Windows, sir.
No, you are wrong.
No,
Linux
sir.
is
Linux is
100%. From security part, from
Yeah,
professional
Linux
work,
is always better, sir.
yes, but
But it's
all of
difficult to operate.
no, it's not
But
difficult.
if you're saying like usability, like most of the people nowadays are not too much familiar with Linux. That is why we just, how to say, moving forward
Then
with
there
Windows.
is the answer
Linux
for
is
your
better.
question. There is one answer for your question. Professional user will use the Linux, but common people use the Windows. That is why in universities, most of the people use the Linux. Okay?
Okay, sir.
Yes, then think like that. Open source programming is not bad. And this is the one pioneer things for the concept of IoT. And based on this IoT open source programming, two boards are introduced in the world. One is Arduino, and the other one is the Raspberry Pi, which we will talk during this course. We have one concept in IoT that in that we call it NB-IoT. NB-IoT are the board or the hardware that are suitable for smart metering, smart cities, smart building, consumers, agriculture environment, and so on, which you have the task to work about this NB-IoT. I will tell you today what you should do about this NB-IoT. But anyway, remember that open source programming is not bad. Then with this introduction, welcome to Arduino board. The board which is based on two concepts. One is that open source. The next one, which these years, I mean, from 3 years back, they start to develop this part much more than others part, and that was IoT section. And I wish that you learned these simple boards with me with this project. First of all, first question, what we can do with Arduino board? First, answer is lots of projects like this that you can see, from LED blinking to hardware parts, LED array, push button, key and serial communication, analog reading, PWM, sensor introduction. These are the parts that we will see. Suppose some sensors like this, you can add some ultrasonic sensors, some servo motors, LCDs, some sensors like DHT, which is the temperature and humidity sensors, some pure temperature sensor like DS18B20, some 7-segment part, some LED jobs, means that 3 RGB LED, and so on. These are the example of the board. But really, if we want to see what is Arduino, Arduino is an open source prototyping platform, which is based on easy to use hardware and software. Maybe you don't understand this easy to use word because you didn't practice with controllers. The previous controllers, I mean, at the time of when I was a student, was like this. When you want to program any microcontroller, you should remove the chip, put it in one tools that we call it programmer, connect it with the serial port to the computer, load on the CD on the IC, and then remove the IC, attach again on the main board, and and see the performance. Then the program has some error. Again, come back, remove, put, program, remove, put it on the main board. That was a little bit difficult, and extra than the cost of the ICs that you purchase, you should purchase one program. Somehow this programmer was not working properly. Somehow this programmer couldn't load your program proper. That was the problem. And that was extra cost. All these issues, I think, forced and encouraged the Arduino inventor, Professor Massimo Banzi, to start to having the board which use the plug and plug-in. And what should be better than USB? Huh? USB is very nice, simple, neat, and good. You can put it and in computers and in Windows also, or in Linux, both. You can use the Arduino. Remember and keep it in your mind that simply you can add to the OS system that you have, and we didn't recognize this USB device. You can upload your program inside the Arduino program, Arduino hardware. These boards are able to read the input, some or even light on a sensors, finger on a button, or Twitter message. Lots of nice things this board can do. And you can tell your board what to do by sending the set of instruction to the microcontrollers on them. So just along with this board, you need one software which we call it IDE, or Integrated Development Environment, and select or do some setting inside the IDE, which I will teach you today. How the board that you have, and establish the connection between the IDE as well as the board that you have. Let us see very what we can see, close look to the hardware. Arduino board, as we select, suppose Uno. Uno in Italian word or Italian language, it means one. There is the history why they call it Uno, because that was the first board that they made. Has 40 important part. Let us see, suppose, what is part 1 and part 2. Part 1 and part 2 can use as the power. Okay, means that with part 1, which is the USB part, you can do dual action. One is that use for the programming part. Second is that you can power on your system. On board, you can see, suppose, ground pin, as it's mentioned in 3, and we have one more also here at the top. You can have 5 volts and 3.3. You can have some analog reading part from which is labeled with A0 to A5. You can have some digital one which are labeled with 0 to 13, and meanwhile you have some PWM part which are used some special symbol like this. One nice thing that you have in Arduino is that whenever you turn your board on, there is one LED which will shows that power is coming. But another nice thing is that when you communicate with serial board on location 12, you can see sending, means that receiving and transmitting data LED which are blinking. And one fixed protocol for all Arduino board is that you have one small LED which is connected to pin number 13, and no need to do any external LED to check the pin number 13. Why they put this? Because regularly the programmers persons, when they want to be sure that the program load proper or no, they use one LED and just make it blink. Okay, like this they preset inside the LED. Meanwhile, we have one other components like regulator, that it can convert the input voltage up to 5 volts, because the controller will use the 5 volts. And this is the main IC, that this shape we call it DIP. We recently they start the SMD part, that we will talk about it later. Besides, we have one more key that we call it reset switch. It's labeled with number 10. Whenever you want to reset your board, you will do. Most of the parts that you will see here are common in all Arduino boards. But before using the Arduino board, I have some steps and some advice for you, that please obey this. First is that for current on the pins or output pins, please be careful. You should not use more than 40 milliamp. Next is that an Arduino can only supply 40 milliampere per output pins. Then cannot drive the motors or speakers directly. For them, you should use some driver. Never, forever, try to connect 5 volts and 3.3 volt and ground pin together. Don't put any connection between them. And also, because the other sides of Arduino pins are out, never try to use this board with some conducted plate, or I don't know, conducted place, or the table. If your table is made on metal, never put it there, because all the pins then will jump together. Something that you should remember is that if you give more than 5 volts or 3.3 to input pins of Arduino, it will kill your board. And even for the jack that we have here, my experience said that the voltage more than 9.5 or around more than 9 will kill the Arduino board. Then for your application, the safer side just for your stage is using the USB. If you want to use the output, it means that another input for your board, use the battery, 9-volt battery, or the adapter or power supply, which is using the 9-volt voltage. Again and again, I tell you that never use more than 50 milliampere from pin 3.3 to connect to suppose sensors and that. And never try to reverse the polarity of the power supply for that. Connecting the loads to V in pin while using the USB power is very dangerous. It will kill your board. And be careful for static electricity, because it will kill your IC and it will go up. Now, with this step, we are going to see what types of Arduino we have. Let me tell you one story. For myself, when I start the Arduino, I didn't know that Arduino have this much time. And just I select randomly one board and start to work. The board that I select was Mega, but really that job is terrible that I have done. But because Arduino was French that time, all the models was not available. We just have Ono, Mega, and Dewey. Okay, Leonard, Micro, Lilipad, Explora, they was not available in my place, and just I had Ono, Dewey, and Mega. Okay, and then slowly I understand that Mega is perfect. I will tell you why, but um, the selection like that, that is the wrong job for any embedded designer person. But I didn't have any other choice. Okay, what we have in Arduino, we have many alternative boards, and these boards are varied in type of the microcontrollers, speed of the microcontrollers or frequency, physical size, number of inputs and output, memory space, and board price. Remember these points, then we will compare them. From um, physical looking of Arduino, you will see that the boards are different even from the shapes, but we have some generation even for them. Current generation for Arduino is Arduino Uno R3. Okay, that we can have it in chip like DIP mode or SMD part. That I personally prefer the deep mode of Uno because if the IC is burned, you can change. But it's very hard to change the SMD part. But funny things that I tell you that now this board is China. It's around I think 15 RMB, 1 Ono. And even last year that was 20. This year it's become less. Then we don't think for replacement and that you can use it. This is Arduino Uno, and this is the board that I use, Arduino Mega 2560. We have other boards, something like Leonardo. We have some board, fantastic board like Uno, like Nano, and some board like Mini Pro that nowadays it's gone. And I will tell you what was the problem for that. This is the recent generation of Arduino from Arduino Uno, Explora, Yun, Mega 2560, Dui, Zero, Micro, 101, Nano, MoPro, and MKR0. And even you can see the figure of Arduino types and generation again here. This is Lilipad, suppose. This is Nano, that Nano is also going to, I don't know, uh, stop the production. Suppose Leonardo also is slowly going to go out. Uno is exist. Explora with some limited application we have, and robots, Arduino robots, it's also limited application. But what's come recently, Uncom, which has the AVR and ARM processor together, Arduino Ethernet W5100 come to picture, which is based on IoT and internet connection concepts will come to picture, and new Arduino top which will be released in future, as I heard from Arduino webpage. Let us have the brief idea about suppose type of the Arduino, and we conclude the comparison between them at the end of today's lecture. Uno was the first one which created in the Arduino world, and it's got everything that you want to start. Nice thing is that you have 6 pin of analog, 13 pin of digital, that's great, and power, and it's invented in 2010 with the form of R3, and it's used vastly between the persons who want to start the Arduino. My advice is that if you want to start the Arduino, take the Uno because it has lots of codes which are in the open source mode and you can easily use it. Leonardo is another one, but nice thing in Leonardo was the built-in USB compatibility, and compared to Uno, it's slight upgrade, but I can say that Leonardo was not the successful product. Even it has a PC as a mouse or keyboard connection there, and you can connect it. But in whole, that was not the successful uh, compared to Ono. Dewey was nice one which used the ARM processor and faster processor and using the 3.3. This board is very similar to Mega from the number of the analog and digital, but my experience with this board is very bad because when I want to extract and use the analog reading, that was terrible, I can say. Even the number of resolution is more, but Dewey was not working much more and it has lots of noise. Anyway, I heard in 3 years back that they're going to stop the product of these, but still I can see some religion and release of Dewey, which I wish that they rectify the problem because using the ARM processor will help more in embedded world and you can have the lots of benefits and speed by using the Dewey. Next one is micro. You will see the USB part is changed and it's become to a small USB part, something like mobile phone type Huawei mobile programmer. You can programming and also give the voltage to that. Nice thing is that like Ono, you have 13 pin here. You have that LED also, blinking LED here. You have limited, I think, as I remember, you have 6 again analog pin, and it's quite nice with the small size and usable for the breadboard. It's fantastic. Um, it's good for the project that you have the size matter and you have the small place to put the microcontrollers. One board come to picture that people will call it lily pad. Lily pad is coming with the concept of wearable device. Wearable device are the device, suppose like the traffic police, that they need some light in their jacket or some any specific controls, okay, that they need. These lily pads come to picture, and what they say that it's popular for closing base or project. As you will see, uh, they can use the uh, some sketching job on the dress and use it. But anyway, I didn't use much more on Lilliput. 2, 3 times I use it. But personally, I think that this board is good for girls, not good for boys like us because we don't have that much ability to see the art through the lily pad. But anyway, this board is also very nice. You can see the 13 pin of digitals as well as 5 pin of analog inside. And again, that LED, blink LED is available on the LilyPad section. Uh, okay, but our target is this lecture is Ono. And now this is the better hardware description regarding the Ono uh, microcontroller or Ono Arduino. You will see here the analog pins and some words like SCL and SCR that I already talked regarding the I2C communication protocol. These 2 pins can act with SCL and SCL. You will see the word TX and RX, which are for the serial communication. It's available. You will see the word of SPI and pin, SCK, MISO, MOSI, SS bar. Huh? You can use. You can use it here as well as here also you can use. Huh? One main controllers you have and one USB driven controller you have on the board that you can use and reset switch. Rest of this part we will slowly be familiar in this course and we can see the performance and working of them. I mean that how they will work and how we can use them meanwhile of our program part. And if we want to have the close look to Lillipad also, this is the last revision, I think, of Lillipad, because compared to the figure that I show you, they have done some change, especially for the programming jack or the USB part. And you will see again that what we have, something like RX and TX as the serial port we have, I2C protocol we have here, and also SPI. As I remember, there was some place like this. I think in the bigger jack also you can use. Yes, here. This is the MISO, SCK, MOSI part, which are connected to the pin number 9, 11, and 10. These are the parts for the Lillipad, which even you can see. Or for the Mega also, another port you will see. TX and RX are there. Controller, digital pin, how many? 52, great. Analog pin, 60, great. And again, you will see the jack and USB jack. Regularly, we will see the Mega with this shape. Even this dark green is the recent form of the Arduino. And you will see the place of the same part. What I mean that after Ono, all the boards have the similar parts of Ono plus something. Okay, means that they have a nice thing in Arduino is that the code that you will use for Ono you can load on Mega. Means that from lower version to upper version you can use, no need to again do the coding. All the language for Arduino boards are same. These pins are ICSP, which you can use the programming of the Arduino through that. And also the SPI communication is there, which I don't know. I tell you in the SPI, in the communication part, that AVR microcontroller, which is the base core of Arduino, they are using the SPI protocol. And by this SPI protocol, you can program and download your code inside the microcontroller. Okay. Then till today we have 20. I think there is more, but 20 are the total list that you can find in Arduino webpage. And you will see the processor, different processor that you use. Suppose in Explorer and with Arduino BT, which is the Bluetooth one, or FIO, you will see that. They use the same as we use in Ono. Suppose for the Mega, they use the 2560. For Mega, ADK is also use the same processor. For Yun, suppose they use the Atmega 32U4, which they use in Matra. Voltage is different, working voltage. Crystal is different. See the Dewey, 84 mega, and see the Mega, 60 mega. You will see, suppose. And based on this processor, based on the size, based on the voltage, based on the speed and crystal, you should select them for your project. But now, because we are in initial stage to working with this word, we select Ono and work with that. But really, if you want to use in your product, you should see the embedded parts and consideration that I tell you. Okay, that was the hardware. What about software? Simple. In the software part, you should just go to Arduino CC, then English main and software part, and just download it free of cost. No need to pay. And I will advise you to prefer the version which need the setup. Okay. And which program we should use? It's very simple again. C++, without 80% of instruction is using them. And any program in Arduino have two parts of setup and loop. Part setup is run the first and once, and parts loops are the repeated part that you are using inside of your program. Let us review some codes. Suppose pin mode, pin and mode, which will tell you the mode of your pin, and you will give the number here. Digital write, when you want to give the output in the digital formats for your pin. Digital read, when you want to read the pin digital. Analog version and analog read, also you have an analog write for this. And serial commands and print on it. This is everything that I'm going to teach you in Arduino. Means that not much more than this thing I will teach you. You will see at the end that you can do the great job with the help of this syntax simply in Arduino board. Okay, that's it for the Arduino, but some people are telling me that how we should find that our board are fake or it's real. Especially they say that they want to have the exact Arduino product. Truly speaking, till these 10 years that I work with Arduino, I didn't see any difference between the fake one and original one, even through the life cycle of product. But it's good for us to know that which board is fake, and remember that the main Arduino board, even you can search on it, the price is uh, much more than something that we can help in China. I think China do the great job in Arduino. I'm very happy and thanking them because at least in various projects I used their board and that was working proper. This part I make from Arduino, and they will tell us how to have the distinguish between the Arduino original board and the Arduino counterfeit one. In the Arduino uh, original one, first point is color. Now the Arduino boards are with this dark uh, color, which previous time that was in blue. Then let me specify, whatever you will get in Taobao, it's not original. It's, I think, fake one, but it's work great. From the other side, back side, you will see that the logo of Arduino should be this, or they changed it recently to this green one. But what we can get is something like this. If you wait for 5 minutes, I will finish this part. It's amazing. The word of Ono, how they make and print on the board, it's something like this. With it should be like that. I mean, this is the fake one. The logo of Arduino, if they didn't print it proper, especially the word of A, is something that company find out that it's fake or original. The map of the Italy as the birthplace of Arduino should be proper, which in the fake one you will see that it's not correct. And the pin quality in the original one and counterfeit one is something that you can see here. The components, the regulator that they use or resistor that they use, it should be in the golden one, but in the counterfeit one, it can be in any other color. But main thing is that, my friend, I didn't see much more difference between the fake one and good one. There is one point that I think I will discuss about it in the next lecture for you, and then it's better to talk about it in the next lecture, which Arduino board is proper for my project, and after that we will going to discuss about Arduino. Any question now from today lectures? Any
No,
question?
sir.
Okay. Then let's go for the task that I'm going to put on the mock system also. Can you see these? Can you see?
Yes, sir. We can see that.
Yes.
Sir.
First is that what is NB-IoT? Another thing is that, do you know any board than Arduino that can we use it in IoT project? Give some name and also some introduction to that. This I will share on book system also, that you can uh, send me the task on mock system. Any question, please? Any question?
Sir, how
No,
many
sir.
tasks
No
you give
question.
us today class? 2 tasks?
What, please? 2 tasks. Yes, 2 tasks.
Well,
Task number 4 and task number 6.
how much time we have to finish it?
Next lecture, as usual.
It's not enough, sir.
It's
For me.
enough. It's enough. Do it, please.
Sir, we have lots of tasks.
No problem, sir. No problem.
You have. If you search, there is not much more things to do. Okay. If you don't have question, we can stop for here, and then